Alvikan Bharti with your mentor Abhilash Sarkar. So in this episode, we will learn how to find the adjoint or adjugate of a matrix. Okay, and further we will see what is the use of this topic in other part of the matrix. Okay, so let's start with the topic called adjoint or that alternatively also called adjugate. Okay, so this is, if I define it, it is the transpose of the cofactor matrix of a matrix. So what do I find first? So I have to find the cofactor matrix of any matrix. Then we have to do the transpose. Then your adjoint of the matrix is available. So if I say a matrix, so adjoint of the matrix is represented by adjoint, and you can put it inside a bracket, or if you simply put in the form of adjoint A, that also okay. Okay, so this is the representation of adjoint. Now you know cofactor matrix, what is that? So before than that, by if I go step by step, so find the matrix with minor, then multiply with the position sign to get the cofactor matrix. So let's see, let's take a matrix A, B, 3, 1, 2, 2, 1, minus 2, and 0, 1, 1. Let me take this. Okay. So first you have to find the matrix with minor. So minor matrix, if I am to establish, so that is equal to how much? Matrix minor of this is equal to 1 into 1, that is equal to 1, minus minus 2, so that is equal to 3. Then further this if I say, so the minor is this is when 2 into 1 minus 0, so that is equal to 2 itself. Then for this is equal to 2 into 1, 0 minus 0, so that is equal to 2 again. Now for this and this, 1 into 1 minus 2, that is equal to minus 1, keep it minus 1. Then for this 3 into 1, 3, minus 0, that is equal to 3. For this 3 into 1, 3, minus 0, that is equal to 3 again. And then for this 1 into 2, 2, minus 2, 0. Then for this 3 into 2, 6, 2 into 2, 2, 4, means 2. Okay, this is minus 2, no? Oh, sorry, this is minus 2, that means minus 6, minus 4, that is equal to minus 10. And then for this and this is equal to 3 into 1, 3, minus 2, that is equal to 1. So let me cross check once what I have started with this. So 1 is this, so this is 1 into 1 is equal to 1, minus 2, 3 is okay. With this 2 into 1, 2, minus 0, 2. With this 2 into 1, 2, minus 0, okay. With this 1 into 1, minus 2, that means equal to minus 1, this is okay. With this and this, 3 into 1, 3, and 0, 3, okay. For this and this will means obsolete. 3 into 1, 3, minus 0, this is okay. For this this is equal to 1 into minus 2, that is equal to minus 2 minus 2, that is equal to 1 into minus 2, that is equal to minus 2 minus 2, that is equal to minus 4. Okay, for this and this will obsolete. 3 into minus 2, that is equal to minus 6, minus 4 10, and for this 3 into 1 minus 4, that is okay. So now this is the actual matrix, so let me write it freshly there. 3 1 2 2 1 minus 2 and 0 1 1. So this is the original matrix, and minor matrix is this one. Now if we put the signed value of the position, this is plus, this will be minus, this is plus, this is minus, so this will become plus, this is minus, this is minus, this is plus. Okay, this is minus, so this will be affected by minus 1. Then again this is plus, this is minus, so this will be affected by minus, so this is plus. So this will be the change. So let me write the cofactor matrix as C is your 3 minus 2 2 1 3 minus 3 minus 4 10 1. So this will be the change. Okay, let me rub this part. Now I have to find the transpose. So transpose of C transpose, if I write, what are the changes? Only the rows become columns. So 3 minus 2 2 1 3 minus 3 and minus 4 10 1. So this will become the adjoint. This on other turn will also say to be adjoint A. Okay, now we don't need this further, so we'll write it here. Adjoint A is equal to matrix 3 1 minus 4 minus 2 3 10 2 minus 3 and 1. Okay, so how do I find? You have already seen, because I have done it step by step. So what I find, I got a matrix. Initially I find a minor matrix with its minor of these elements. Then I have imposed the sign effect on the matrix that is formed by the minor. Then I have taken the transpose to find the adjoint. So this is the process. So first minor, then sign effect, then sign effect, then transpose. So these are the 3 steps to find. So you will land up with adjoint. Okay, so this is the process. Now what I am to use this to find the inverse of matrix, because that part has left without explaining. What I said, I was explaining some property of matrix that is said like that A inverse is equal to identity matrix. So I said, for explain that, I first need to explain the multiplication that I have explained, and further I have to find the inverse of that. Okay, so inverse of that, any matrix, the inverse, the next topic I am keeping this because this will be useful to find inverse. So inverse of a matrix, so this will be my second topic. I will let it be, let I write it there on the top. Inverse of a matrix. Inverse matrix you can say in one term. Okay, so this can be done with 2 methods. First one is determinant method, or you can say with the help of the determinant. Second one is element transformation method. So these are the two methods. Other methods, usually people say there is a third method, but this is one way of the determinant method, where at the end we'll find some formula. They are saying there is another method, but that is in turn same as the determinant method. So I am not distributing in other third method. Rather, I will explain there where the third method comes in picture. Okay, so basically this is being you can say are two method being involved, that are determinant method and means that can be you can separated or classified into these two methods only. So that is determinant method and element. So let me take this first, the determinant method. Why? Because determinant method, the formula of finding A inverse is the adjoint A. So that means this is a matrix divided by the determinant A. So this is the formula for finding the A inverse determinant. So now if I go with this, so adjoint you already find. How to find the determinant? You know what you have to do. You have to just expand this matrix. To expand this matrix with a row, with the row. So that means 3 if I take. So then you have to multiply with 1 this. That means 1 into 1 1 minus of minus 2 into 1. So that will give you plus. Alternate sign will be minus because they started with plus. Second element of this row into 2 into 1 minus 0, that will be 0. So 2 and in turn that will be plus, because this is anyhow minus is coming, so you can put it minus. Okay, because the terms is this into this minus of, so that says 1 into 1 minus of, as because this is multiplication of minus into 0, but minus if in case that digits are coming, so that sign will become plus. So for this first case 1 into 1 minus 2 into 1, so that's why this minus minus will become plus. Okay, so this you can understand, but the formula is you have to deduct the multiplied elements. So this cross elements minus the cross elements, you have to do like that. So the third term is again plus an element into its minus, that means 2 into 1 minus 0, so that will be 2 minus 0, you can say. So if we calculate this, 3 into 3, that means equal to 9, this is equal to minus 2, this is equal to plus 4. So all together it is how much? 13 minus, that is equal to 11. So your determinant adjoint value will be 11. So now if I put this this is 1 upon the determinant, so this is 1 upon 11, and rest of the matrix you have to write like that: 3 1 minus 4 minus 2 3 10 2 minus 3 1. Now any value outside this are called the scalar, and the operation, the scalar with the matrix is it will multiply with the all the terms. So that is the scalar multiplication we have already done. I have explained with scalar k, where when it is multiplied with the matrix, that will be multiplied with all the elements of the matrix. So we do the same thing here. Okay. So the matrix will I will not write it again. So what I do, this 11 will be multiplied all the terms. So this will come as 11 on the denominator of the all the terms. Understand? So this matrix will turn into this form. So this is your A inverse. So by that you can find the A inverse. Okay, this is one way of finding. the A inverse. Another method is elementary method, but prior to that I would like to prove this part. This part is very much needed. Okay, so to do that I need what, this and this in picture. So I will rub it for time being and I will write the inverse here in the form of 3 by 11, 1 by 11 minus 4 by 11 minus 2 by 11, 3 by 11, 10 by 11, 2 by 11 minus 3 by 11 and 1 by 11. Okay, so this is the another matrix. Now you have to multiply this. So multiplication is multiplication is just to get this result, A into A inverse. So this is two matrices we are multiplying, and the rule says, if I, what I have to do, I have to multiply the row, first column to get this element. For second element, row and column will change accordingly, because when we are moving towards in a particular row, then the row will be fixed and column number will change consecutively. The first element by first row, first column, second elements of the same row, second row, first row, second column. Now if you want to move this way also, so in that case you have to vary your rows. So for this first row, first column, for this second row, first column, like that you have to do. Okay, so don't be confused, you just follow one orientation. For this element, first row, because this is position what, I and j is 1 and 1. For this 1 and 2, this is 1 and 3. For this is 2 and 1. So 2 means second row, 2 means second row, first column. This is for 2 and 2, second row, second column. So if you can remove the position, you accordingly can choose the row and column accordingly to find the value. So just keep it in mind and then follow any one orientation. Don't do all at a time, so then you can make mistake. So I will go with, this is row 1, row 2, row 3. This is column 1, column 2, column 3. So row 1, column 3. So this is 3 into 3 means 9 by 11 plus 2 into minus 2 by 1. So this will become minus of 2 by 11, and the third one is 2 into 2, that means is equal to plus 4 by 11. So this is my first term. Second term, row will be there, row into second, this one. So 3 into 1 means 3 by 11. Second one, 1 into 3, so that means again 3 by 11. Third one is 2 into this one, so minus 6 by 11. Okay, third term here. Okay, can follow me. 3 into row 3, so that means 3 into 4, that means minus 12 by 11 plus 1 into 10 by 11, 1 into 10 by 11 plus 2 into 1 by 11, that means 2 by 11. That finished. So this is done. Again 2 into this first 6 by 11 plus 1 into minus 2 by 11, so minus 2 by 11 minus 2 by 11, so that means minus 4 by 11. This is done. Second, 2 into 1 by 11, this is 2 by 11. 1 into 3 by 11 plus 3 by 11, and this is minus 2 into 3, that means is equal to minus 9 by 11. Let me check, because this is not the thing coming. 2 into 1 by 11, 2 by 11 1 into 3 by 11, 3 by 11 minus 2 into 2 plus 9 by 11. Where I am mistaking? This is 2 by 2 into 11, 3 by 11 minus 6 6 by 11, sorry, 6 by 11, yes, 2 into 3, that means 6 by 11. Okay, then this is 2 into third row, that is equal to minus 8 by 11, 1 into 10, so that is plus 10 by 11, minus 2 by 1, that is equal to minus 2 by 11. Okay, and the last one, this is done. Last one, 0. So 0 into this will give you 0. 1 into this will give you minus 2 by 11, and then 1 into 2, so that is plus 2 by 11. Fine. Then second row, second column, third row, second column, that is 1 by 0, sorry, plus 1 into 3 means 3 by 11, and 1 into minus 3, that is minus 3 by 11. Last one, 0 into this 0, 1 into this 10 by 11, and 1 into 1 into 10 by 11, and this is plus 1 by 11. So this is all. So this you have to be little bit cautious when you are doing such big multiplication, because there is no other way of doing these things. So other method of production, because this is the rule where you have to do the product. Okay, now fine. So during this kind of problem you have to be little bit cautious. That is the only thing I can tell. Okay, otherwise everything will goes wrong. So this is every denominator having 11, so that LCM will be 11 for every time. So only thing you have to calculate. So that's why I am not change into any fraction. Even if it is, there is a possibilities of changing the fraction, don't change it, because if this is the one trick there, this would be same, then your calculation will be faster. Okay, so don't change the fraction. So 9 plus 4, that is equal to 13 minus 1, so that is equal to 11. 11 by 11 is equal to 1. Okay, this you see 6 minus 6, 0. This is also 10 plus 2, 12. This is 12, so that is equal to 0. This you can see 6 and 6, that is 0. This is 2 plus 3, 5 plus 6 is equal to 11. 11 by 11, 1 again. This you can see 10 minus 10, that is equal to 0. This is equal to 0. This is equal to 3 minus 3, 0 is already there, 0. And here 10 plus 1 is equal to 11 by 11. So you can see this is turned into a identity matrix. Okay, so any matrix with its inverse, if I multiply, I will get a matrix which is a identity matrix. Okay, so this is one rule you can say. So that also can be said like that, if two matrices are multiplied and you will get two matrices where you don't know whether it is inverse. If I get a identity matrix, then A and B are alternately the inverse of each other, you can say. So A could be inverse of B, or B could be inverse of A. This both can be possible, because if I take two matrices and this I find inverse, the identity matrix, then you can say either A be the inverse of B or B be the inverse of A. That is possible to say. Understood? So this is one rule that you can establish by this process. Okay, so I will stop it here. In the next episode I will start with the process of doing elementary transformation method. Okay, so thank you for now.